Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about properties of a group with examples. We are going to show you the proofs. So, in our last classes, we already discussed about the group and its basic understanding. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class. So the first property is the identity element of a group is unique. Means in a group we are having unique identity element. Hoping that you already know the basics of what's identity element means, what is inverse means from our previous classes. So based on that we are providing the explanation. So in order to show this, we assume that E1, E2 be two identity elements. We are assuming that E1, E2 are two identity elements. So from the identity elements, we already know from our previous basics, any element, binary operation with identity element, you are going to get A. E1, binary operation A, you are going to get A. This is the group property in our last class which we discussed. Similarly, you take this E2, binary operation E1. We are assuming that E2 is identity element. E1 is another identity element. Any one multiplied by identity element, you are going to get E2 or E1. This happens only if these two are same. Otherwise, it won't happen. So that's why in a group we are having only unique identity element. So this is what the first property says. The identity element of a group is unique. We are having only one identity element. Coming to the next property, every element in a group G has unique inverse. We are having unique inverse. That is what we need to understand. We are assuming that A1, A2 are two inverses for an element A. From the properties of the group, we already know that in our previous class, A binary operation, this is A1 is the inverse for A. We are going to get identity element. Similarly, A binary operation A2, we are going to get identity element. Now we need to show that now we are assuming that A1, from A1, you take an element A1, this can be obtained from A1 binary operation identity element, you are going to get A1. These three things we know from our basics group conditions. So now from this we need to show A1 binary operation E. In place of E, we can write A binary operation A2. So A1 binary operation, A binary operation A2. Now in a group, we can apply associative property because associative is accepted for a group. So these brackets can be obtained any place. These brackets are changed. A1 binary operation A, binary operation A2. We already know A1 binary operation A is equal to E, identity element, because A1 is inverse of each other. That is what our assumption. So E binary operation A2, that is equal to A2. A1 equal to A2. That is what we showed. So you take two inverses for an element, it is not going to happen. Those two are same. Then only it happens. Means we can say that for every element we can have only one unique inverse element. Similarly, the next one is in a group, we need to show A inverse whole inverse is equal to A. For this, in order to show that A binary operation A inverse is equal to A inverse binary operation A equal to E. This we already know from our previous classes. Now take this A inverse multiplied by binary operation A equal to E. For this, on both sides, right hand side and left hand side, we are adding A inverse whole inverse. Nothing wrong with that. We can do the binary operation. A inverse whole inverse binary operation, A inverse binary operation A equal to, on the right hand side we added A inverse whole inverse binary operation E. Any number binary operation with identity element, we are going to get the same number. That's why these two, we get A inverse whole inverse. And on the left hand side, we can apply associative property, associative law. Means these brackets can be applied to any side. So this is how we have written. A inverse, whole inverse, binary operation, A inverse. Take A inverse as X. X multiplied by X, binary operation, X inverse. What you are going to get? E, identity element, X, X inverse. Identity element, that's what we got. E, binary operation, A. You are going to get E, binary operation, A means A. So we had shown A equal to A inverse, whole inverse. So that is what we need to show. A inverse, whole inverse is equal to A. Now coming to the next property in a group, A binary operation B whole inverse is equal to B inverse binary operation A inverse. In order to show this, these two conditions we already know. If you assume that A inverse are the two elements, A binary operation A inverse is equal to A inverse binary operation A equal to identity element. Similarly, B identity element. So now we need to show that, assume that here we are showing this. A binary operation B binary operation B inverse binary operation A inverse. Why we have taken this? A binary operation B AB. We are assuming here that A star B whole inverse and B inverse binary operation A inverse, these two are same. We are assuming. So if you assume that the given is true, A star B binary operation, you consider this as X binary operation X inverse, you are going to get identity element. X inverse means A star B whole inverse. We are assuming that this is equal to this. So in place of A star B whole inverse, we are placing this. So A star B whole inverse. In place of that, we are placing B inverse binary operation A inverse. We are assuming that these two are same. So from this, if you take this and if you show this is equal to E, then we can say that those two are equal. So that is what we are going to do. So from this, we take the right hand side and show it as, take the left hand side and show it as E. E means identity element. Now this group is going to satisfy associative law. These brackets can be placed in anyhow. Any way you can place the brackets. So now we are taking B star B inverse star A inverse. We are taking it as one bracket. So from this again you apply B star B inverse as one bracket. A star B inverse star A inverse. This can be written as E because B inverse. E. A star E star A inverse. E star A inverse means A inverse. A star A inverse means E. We had shown that by this from here we are going to show it as E. Then definitely A star B, this is as A star B whole inverse. In place of this, we place it as B inverse star A inverse because these two are same. We can conclude that these two are same. Now coming to the fifth property, cancellation law. This is very easy to understand. A star B is equal to A star C. Left hand side, right hand side, both are same. A. Then we can cancel that. Then we can say it as B equal to C. Similarly, B star A equal to C star A. Right hand side, we can cancel. Is it possible to cancel that? Yes, in a group, it is possible to cancel that. B equal to C. Let's understand. We are going to show only for one, the first one. The second one, you can try it on your own. Let's take A star B is equal to A star C. We are assuming that A star B is equal to A star C. Then on the both sides, we add A inverse. Adding that A inverse is not a problem because both are same. So A inverse star A star B is equal to A inverse star A star C. You can apply associative property. These brackets can be placed to either side. A inverse star A star B. A inverse A means E. E star B means B. Similarly, on the right hand side, A inverse star A is equal to E. E star C is equal to C. So from this, we are showing that B equal to C. So you can apply cancellation law. Hope you understand the properties. These are the 5 properties which we very important on the group theory. Hope you understand these properties. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.